Hi, I'm Alec Tubbs, and this is my lab report for our first lab. First, I'll be giving a brief introduction about the lab itself. This lab deals primarily with the fact that many household objects can be charged to either carry an excess negative or positive charge. These charged objects then create electric fields around them, which interact with their surroundings. In the picture to the right, with the picture of the cat and the balloon, the electric field created by the charged balloon causes the hairs on the cat's back to stand up because the two are attracted to each other. We simulated this ourselves using pieces of charged tape. To charge the tapes, we placed one strip of tape on a table and then quickly ripped off another strip of tape, effectively charging this tape. We then observed that if we placed our hand close to the tape, it was attracted to our hand. The next step of the lab was to figure out just how big the charge on the tape was. To do this, we created two charge tapes. The one was suspended in the air with a little sag in the middle, and the other one was placed as close to the other one before the one was suspended, effectively counterbalancing the gravitational force acting down on the tape. Once we knew this distance, it was relatively simple to calculate the charge on the tape, given some assumptions. The main two physics concepts at work here are Coulomb's law and the idea of gravitational force. Coulomb's law, whose formula I have shown to the right, essentially gives you the magnitude of the electric force on one charged particle due to another charged particle. Gravitational force, which is proportional to mass times gravity, is the force that any mass experiences due to gravity. In this lab, we're essentially equating the two, saying that the gravitational force on the one tape is going to be equal to the electric force pushing upwards on the other tape. Another physics concept at play here is the fact that neutral objects can gain charge by either rubbing them on something else or ripping them off of something else in the case of the tape. Here are some of the results and measurements from my experiment. I measured the length of the tape to be 20 centimeters or 0.2 meters. The weight of the tape, given that 1 meter of tape is approximately 1 gram, was 0.2 grams. The sign of the charge of the tape was negative because I charged a plastic pen and placed it near the tape and the two were repulsed. The separation tape, when trying to float the one tape above the other, was approximately 1.32 centimeters. Because of this, the charge of the tape was calculated to be negative 6.16 times 10 to the negative 9th coulombs, and the number of excess electrons was approximately 3.85 times 10 to the 10th electrons, and the ratio of electrons to atoms was 9.63 times 10 to the negative 8th electrons per atom. Here are my calculations. First, to calculate the gravitational force experienced by a piece of tape, I multiplied the mass of the tape, 0.2 grams, by the acceleration due to gravity, 9.81. Knowing this, I knew that in order for the tape to be suspended in the air, the electric force must be equal to the weight. I, at this point, knew the separation distance between the two tapes, so I was able to plug everything into Coulomb's law and solve for Q. I found Q to be 6.16 times 10 to the negative 9th coulombs. To then find the number of electrons, I divided 6.16 times 10 to the negative 9th by the charge of one electron to get the total number of electrons. Once I knew the total number of electrons, to find the ratio of electrons to atoms, I first had to calculate approximately how many atoms were located on the area of tape that I had. I did this by assuming that every single atom was essentially a square and that there was no distance between them, and found there to be 4 times 10 to the 17th atoms. Once I knew this, I divided the number of electrons by the number of atoms to figure out the amount of electrons per atom. Here are the results of the code that I wrote. The red sphere on the left represents the tape that's being suspended in the air, and the blue sphere represents the tape that is in place being moved close to it. The orange arrow pointing down is the force due to gravity, and the green arrow pointing up is the electric force. While coding, I had to assume that both tapes acted as point charges, and this is shown in the picture. Also, according to my code, given a separation distance of 1.35 centimeters, the magnitude of the charge would be 6.3 times 10 to the negative 9th coulombs. In conclusion, I'll answer some of the questions that were on the lab assignment. The first one, what would happen if electrons had a positive charge and the protons had a negative charge? I don't think this would really change much, as there would still be something with a positive charge and something with a negative charge. So in the case of this lab, instead of the tapes being charged negatively, they'd be charged positively, but they'd still repel each other. So the one tape would still be able to essentially float there, overcoming the weight due to gravity. To answer the second one, why is it important not to handle the tape too much? I think the answer to this one is that if you handle the tape too much, then the charge will disperse itself and transfer along your fingers to your arm, and then it will no longer be charged.